I will introduce my project from the following 5 parts. First part is about the background of the subject and content. So firstly, I have a question. What is the pseudo-relevance feedback? It is a method. The method is to do normal retrieval to find an initial set of most relevant documents, to then assume that the top key ranked documents are relevant, and finally, to do relevance feedback as before under this assumption. Pseudo-relevance feedback aims to reduce the effect of query passage, vocabulary mismatch, and thus improve search effectiveness by modifying the original query using information from top-ranked passages. There are some common drawbacks. Pseudo-relevance feedback methods typically perform averaging over the top retrieved documents, but ignore an important statistical dimension: the risk or variance associated with either the individual document models or their combination. Part 2, current problems and algorithms. Uncertainty is an inherent feature of information retrieval. Not only do we not know the queries that will be presented to our retrieval algorithm ahead of time, but the user's information need may be vague or incompletely specified by these queries. Current algorithms for pseudo-relevance feedback tend to use vector space-based algorithms, such as Rotrow's formula. For these algorithms, firstly, a set of top retrieved documents is obtained from the initial query and assumed to approximate a set of relevant documents. Secondly, a single feedback model vector is computed according to some sort of average, centroid, or expectation over the set of possibly relevant document models. The document vectors may be combined with equal weighting as in Rotrow, or by querying likelihood as may be done using the relevance model. The use of an expectation is reasonable for practical and theoretical reasons, but by itself ignores potentially valuable information about the risk of the feedback model. Let's talk about part 3, research ideas and the process. Firstly, I want to introduce the main hypothesis. The main hypothesis in this project is about that estimating the uncertainty in feedback is useful and leads to better individual feedback models and more robust combined models. Therefore, I proposed a method for estimating uncertainty associated with an individual feedback model in terms of the posterior distribution over language models. So this is a picture about estimating the uncertainty of the feedback models for a single query. We can get 3 information. The first one is the inputs to the baseline feedback method. And the second one is the feed Dirichlet distribution to the output. The third one is the use the posterior mean or mode as an improved feedback model estimate. In order to obtain the better performance for this project, I use the following methods for generating variants of the original query. Each variant corresponds to the different assumption about which aspects of the original query it may be important. There are three methods. First one is not expansion mode. Second one is leave one out. Third one is single term. Finally, using different and many query variants, the results of the enhanced feedback models are usually combined by the use of the bias model combination. For expansion performance, feedback algorithms effectiveness by two main criteria. The first one is precision, second one is robustness. This part is about resampling expansion. For each query, I obtained a set of B feedback models using the usual baseline. Each feedback model was obtained from a random sample of the top K documents taken with replacement. On the query side, I used leave one out sampling to create the query variant. For the resampling expansion, estimate an enhanced feedback model from the Dirichlet post-row distribution for each query variant and to combine the feedback models from all the query variant. In order to evaluate robustness in this project, I use a very simple method. It is RI cubed. The RI method is defined as this formula. So the N plus is the number of the queries helped by the feedback method. N minus is the number of the queries heard. From this table, we can see the average precision of the resampling method was comparable to baseline method, achieving an average gain of 17.6% compared to using no expansion method across the three collections. The usual baseline expansion gain was 17.25%. The resampling method achieved consistent improvements in P10 over baseline method for every topic set, with an average improve of 6.89% over baseline method. From this table, we can see resampling method obtain higher value than baseline method on robustness index. Let's talk about the final part, evaluation and conclusion. Firstly, this part is about effect of resampling on expansion term quantity. So the retrieval model should not require a stop word list when estimating a model of relevance. And the second one, the robust statistical model should downweight stop words automatically depending on context. Stop words can harm feedback if selected as feedback terms because they are typically poor discriminators and waste valuable term slots. Because most term selection methods resemble a TF-IDF type of weighting terms with low IDF, but very high TF can sometimes be selected as expansion term candidates. Let me make a conclusion. For this project, the overall use of the query which has been analyzed in this research will help in the formulation of many models, which will help in coming up with the expected outcome. One is model combination will also be an important aspect to consider in the research, as it will help in analyzing the terms and arranging them in the format which allows the most relevant documents to occupy the higher ranks and the less relevant documents to occupy the lower ranks. Thanks very much for watching my seminars. Thanks.